you today?
This is I don't know if you knew or not, but my cousin's band is breaking up. So their last show is at 7 o'clock at the St. Joe Methodist Church on Friday.
Oh, okay.
So if you wanted to go.
Thank you. Because they're moving.
Yeah, they're going to all different places.
That's a bummer. I didn't realize it was like breaking up.
Sometimes only, sometimes never, sometimes never, sometimes only, sometimes.
She knows my cousin.
Oh.
But I get that. I don't think they're learning.
Well, why would you say that? I guess I'm like, yeah. I do want you guys to talk with each other about it first, but then we will.
Always.
Sometimes
Always, Hannah.
always.
Sometimes always.
I have always,
I
have never, never.
When?
Seven,
What they were.
Yeah, I want to look what they were. Always, and then 10. I said always.
Yeah. Hannah always. Wait, no. Yeah, the second one. What do you have sometimes for the third
We
one?
have
Yes.
one
I,
for
I
always.
had always for with a question mark because I wasn't sure. Can you please explain number 3 to me?
Okay.
1,
5.
So I got basically
Two similar polygons are always sometimes or never congruent.
Why is there simple polygons? Why were there all?
Sixes.
Because they could be like.
So one.
Oh, but it could be always.
They can have different
Yeah,
sides.
like these.
Because it could be like,
Two rectangles.
this one could have 3 and this could have 1. Or like, you know how like some things are divisible, like
Yeah, but they always just
4 and 2
Because like the length
But
of
to
the
be
side.
and
to be similar,
something else could have
So we'll go with
side
something.
lengths
2 and then divided.
Portion of the side.
It'd be an odd number,
Yeah,
like
yeah,
3.
yeah.
That makes sense.
Like,
So sometimes for that one?
yeah, that's actually
Sometimes.
4 to 6.
What do you guys have for?
Would you
You
do
don't actually need to
What
put
about
always.
Me too, but I put sometimes.
I had never, and then I.
Well,
I'll
figure it out when
he
he
asks.
asks.
So I was like, I only get 0.
Yeah, I know,
She's gonna.
I had
another.
I'm just
I
saying
would- I
that
just
if
remember
you
depending on
put
the
sometimes,
No, that's it.
I mean, if you put always, it's a general statement that it's always, but sometimes.
Well, they don't have to be congruent.
But
It's kinda like,
yeah.
yeah, I know, but it's like in between.
Yeah, I couldn't visualize it either.
Right
You know,
now,
like they
so.
what they
Well,
put.
they put the have like a negative shape.
Wait, what?
I just
but
mean
you
if
have
you
like
put
a 0.
What do you have?
Like,
But
If you want
it-
to always
Yeah,
and
it's about that,
sometimes,
they
then
can
you
just
can
be
put
similar, not
sometimes.
That makes sense.
Because we got
I
this
didn't
message,
think
so
about
I
it.
put
I
that
don't know.
down. 'Cause that's
Always
The sides have to be.
So.
I did sometimes
this
I did
is
sometimes.
the question.
And the sides have to be. I had sometimes for 8 as well.
Oh, the sides have to be like.
Yeah, I have, but I wasn't sure about
Don't
the
really
last three.
understand, but I see.
Neither.
Hey, you guys
I
wasn't sure
Wait,
any of
just
them.
run through it really quick.
Yeah.
Okay,
I don't know
so
what the word
sometimes,
is. Yeah.
Always.
Yeah.
sometimes,
Yeah.
never,
Yeah.
never.
Yeah.
I didn't remember.
I had never for 5.
And then, we were kind of iffy about 6. You said sometimes, I said always.
We all had
I said
always for.
I had.
Yeah, I've always.
Wait, but why?
Because
Like, you could have weird numbers, right?
Well,
That's
6-1.
the-
That's their
yeah.
Like
6-1.
.2.
Oh, okay.
Oh, okay.
So that's definitely all.
And then 7 sometimes,
Yeah.
8 always, but
I had some.
he said sometimes too.
Yeah, I said sometimes for
Okay,
8.
and then 9 always.
Yeah.
And then 10, I said always, he said
I had
sometimes,
always
said
for 10.
Okay.
I was iffy on the last 3.
What?
For 10. What's number 10? Yeah.
The question is, if the perimeter of triangle ABC is 12 and the perimeter of
Do you have
triangle
sometimes?
E is 17.
I really
The
wish I
ratio
was.
of AB to DE
Oh, you have,
is
oh, I have always for 10
always
as well.
12
Okay.
and 17.
Cause like, you can't.
Yeah, but
I know, it was way more like, I think that's always, I wasn't really sure why, because the side, so,
It would have to be smaller. The side can't be just as long as the perimeter.
I just felt it in my soul, it was telling me.
Oh, yeah, because it'd just be one-sided.
Crayola.
So,
Okay. So number 1 would be what?
Sometimes.
Sometimes. Number 2.
Always.
Always. Good. Number 3.
Sometimes.
Good. Sorry, I hadn't read it all the way through yet. Number 4,
Never.
right, because they are different sides. Number 5,
Never.
the perimeter of a polygon is, we're disagreeing about that.
Yeah.
So, who would like to present their argument?
Sarah would.
Marie?
Well, I was thinking like sometimes the sides could be like 0 point something, and then all together it could add up to be 1. I wasn't sure if that was possible, but
Yes.
that was my thinking.
That would be possible. I think that's a good argument. So, sometimes. Number 6, if polygon 1 is similar to polygon 2, polygon 2 is similar to polygon 3, then polygon 1 is blank similar to polygon 3. Always, that is like the transitive property, and we said that the similarity is transitive. If 2 polygons are regular polygons, the polygons are, that would be always, because that's like a square. Because if they're regular, that means all of their sides are congruent and all of their angles are congruent. So the ratio, the proportion would be the same and the angles would be the same. So that's like a square, for example. So it'd be always. That you would have to assume they have the same number of sides, but I'm guessing that they made that assumption. If an angle of one rhombus is congruent to an angle of another rhombus, the 2 rhombuses are. Did anybody say always? Yeah. Would you like to present your argument?
For 8. Yeah? Is that for 8?
Mm-hmm.
Yeah, okay. If an angle of one rhombus is congruent to another angle of another rhombus, the 2 rhombuses are, I said always because because with a rhombus there are 2, like the 2 opposite angles are congruent and then the other 2 opposite angles are congruent. So if this angle is congruent of this rhombus, and then it's the same as that rhombus, that means these 2 are congruent and these 2 are congruent, which means those 2 are congruent and those 2 are congruent, which means they're both congruent, which means they're similar.
Okay, I got lost.
And there's one other factor to consider.
Oh, I didn't consider any factors. It's just
Well, what 2 things, you're right, so you can be confident.
Okay.
You're right, it is always. What 2 things does it have to be similar? Paige? The lengths have to be proportional, and what do we know about rhombuses?
that all the sides are the same.
The
right?
sides are all congruent, so no matter what kind of rhombus it is. If one angle, what Hannah is saying, is if I know one angle of a rhombus, I can figure out all the other angles. So, because they'll be, so if this angle is 120, I can figure out all the other ones, because this would be 120, and I know these 2 are congruent, and they have to add up to all be 360. So, even if I just know one angle is congruent on the rhombus, all the other ones will be congruent, and since rhombuses have all sides congruent, their sides would be proportional. So that would be always. Does that make sense? Okay. 9. If quadrilateral ABCD is similar to quadrilateral HIJK, then quadrilateral HIJK is always similar to quadrilateral ABCD. That is the symmetric. Remember yesterday when I was like, you all said, oh yeah, that's right, but we didn't remember what symmetric means. That's symmetric. If the perimeter of triangle ABC is 12 and the perimeter of triangle DEF is 17, then the ratio of AB to DE is 12 to 17. Always. Yes, that is that second theorem. 6-2, because their ratios will be the same. The ratio of the perimeters will be equal to the ratio of the. Yes, me.
I put never because like when I read it, I thought like A, B, and D, E were sides. So if the perimeter is 12, how could a side be?
It would be the ratio. The ratio would be 12 to 17. So it wouldn't be exactly 12 and 17, but they would be numbers that when we wrote them as a fraction, they would reduce to 12 over 17. So that it's not gonna be equal to the perimeter, but the ratio of the sides would be equal to the ratio of the perimeters. Okay. Alright, if you guys does anyone have any other clarifying questions on this? Okay. If you would get out your notes, we're gonna do at least one example to help you get started on the next part. Okay, if I know that quadrilateral ABCD is similar to quadrilateral RSTW, and here is A, B, C, D, and here is, I didn't do a very good job, RSTW is bigger. RSTW, and I know the following sides. AB is 4, RS is 6, RW is 8, WT is 7, and ST is 9. Then I need to find the remaining sides. So we will call them X, Y, Z for short. Does anyone have an idea of how we might go about doing that? Okay.
4 to 6 is the same, well, like AB and RS is the same angle, so the ratio is 4 to 6, side, for that side. And so, if we made all the other sides ratio 1 to 2, would that work?
If we made the other sides what?
Ratio, like Z to 8, like if that was like 1 to 2 kind of.
1 to 2, or both?
Want to be 2 to 3?
Right. You're right, Sarah. So this is what we need to look at. We have one pair of corresponding sides that we know both of the lengths for. And so we'll write that as a ratio, and we would simplify it just to make our lives a little bit easier when we're finding the rest. So we know that the ratio of all of the sides to the other sides is 2 to 3. So we can set up proportions. It's all, really, there's a lot of different ways you could go about doing it from here. I would probably set up proportions for the rest, but you could do it however you wanted to do it. So, for example, we could say Z, we're looking at Z over 8 equals 2 over 3. And then to solve that, we would cross multiply, so we have 3Z equals 16. So Z will equal 16 thirds. You could just leave it like that. And just be careful that, notice that the 2 is from ABCD and the 3 is from RSTW. So we need to always put the side that we're looking at, so in this case, the Z comes from the ABCD, that goes on the top with the 2, and the 8 goes with the 3 on the bottom, so that does make a difference. So if you wanna always start with the smaller, and then do the larger, or you could do it 3/2, you just have to make sure that it's lining up, does that make sense? So like if you pick ABCD on the top, then everything from ABCD has to go on the top. So how would we find the rest? How would we find X? Morgan?
X over 9 equals 2 over 3, and then you cross multiply.
Good. So we have 3x equals 18, so x will equal 6. And then we need to find y is the last one. So what would be the proportion for y? Mac?
Y over 7 equals 2, 3. And y equals 14.
Good. Okay. Questions about that? Okay, then your homework is page 201 to 202, numbers 19 through 28. You have lots of time to get started on that, so let me know if you have any questions.
I was thinking it went this way, because it's useful.
Oops, my wish is gonna let you hear. Miss Faulkner, how do we do triangles? Cause there's like 23 and 24. Cause there's not a side that we can like get the ratio from.
For those, they told you the perimeter underneath. That's the perimeter for them. So you'll need to use the perimeters to find the ratio.
How do we do that?
You
Oh, the
would,
perimeter of the second one.
you would add up the sides of the one that, of all the sides that are given to you.
Oh, okay, I see, thank you. Do I need to take this away from me?
Whoa.
You do the perimeter. Like, this is the perimeter of 12, and this perimeter is 18. So 12 over 18 is 6 over 9, and 6 over 9 is 2 over 3. So you just do it, and then the ratio is 2 over 3.
I didn't understand any of
Okay,
that.
so this one is 12, right? Do you see where it says perimeter is 12?
Oh,
Yeah, and then this one up here, if you add them up, is 18. So 12 over 18 equals 6 over 9. Got that?
yeah.
Okay, is 6 over 9 is 2 over 3.
I didn't see the bottom thing, so I was like,
Yeah,
where
neither
you
did
this
I.
numbers?
Neither did I.
Yeah, I know. I'm not sure how exactly.
So you're not on team. That's okay. I'm only on 23. Yeah, so I'm only 2 of 5. That's okay.
Oh, that's right, you're the next year.
Wolfie, number 24. Just kidding. Okay, just making sure. Don't give me that face, you mean? So cute.
I just got 6. Wait, which part? Okay. That's 5 and 6. I just got 6.
Yeah, but it's starting at 4.
What? Which I have to tell you. 22. D is 15 over 6.
Oh, I didn't. I didn't.
You did?
35 over 3.
Oh, Z is 5
I
over
got
3.
instead,
I mean,
I did.
Did you get 5 over 2?
3 over 2.
Did you get 5 over 2?
Over X.
Got 5 over 2 for Z.
12.
Yeah.
Yeah.
Okay.
Two.
And then Y, 3 for 20?
6.
No, I got 20 over 3.
6.
Yeah, it's 20 over 3.
Because I switched these, it's the same thing.
Are you sure?
So it's,
I feel like
let's see.
Wait, you got 36 over 5?
No. I got 5 over. Oh, no.
No, I got 36 over 5.
I got
I got 36 over 5. Okay, so Y over 8.
What'd you get for 21?
Oh, okay, I did 20.
I got
Thanks, guys.
40 over 6, 13 over 25.
Oh, you can't reduce them.
Oh, yeah, no, I didn't. She said we didn't.
Oh, we have the same.
We don't have to
Yeah.
reduce? That's fantastic.
Yeah.
Mr. Bly would take off points.
That is reduced, you just don't
Oh, yeah,
have
you
to
don't-
write
well, you
them
have to make
as
them
a
into-
decimal.
Yeah, that.
So like,
So reduce the fraction to this point.
so 6 over 9 isn't acceptable? Darn.
It's not that much work to change it.